Good evening, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. For more information, you can also visit our website www.sapienceeducation.com. If you want full courses and all the materials, you can also download our app, which is now free. And the link of the app I have given below in the comment descriptions. Okay. Today I am going to teach you work, power, energy. What is work? What is work? What is power? What is energy? Now, it is said to be done by a force when the point of application of force is displaced, transferring energy to or from an object so that there is some displacement of the point of the application of force. Let us consider an object is there and it is at the horizontal level, and if I am applying a force at this point, so if object gets displaced, then work is said to be done. Work is said to be done by this force. Work is said to be done by this force. As this force is responsible for displacement. Okay, I am not talking about here gravitational force and all. Only this force. Due to this force only this object is moving. So that's why due to this force work done is okay. What is energy? It is the capacity to do work. The more you will able to do work at a less time, so you will get the energy. It is the capacity to do work. The more energy you have in your body or any machine, the more work it will be. Okay. So energy is the capacity to do work. What is power? Power is your rate of doing work. Okay. So the more you work at less time, so the more power it will be. So for increasing power, we should work very high at less time. So power depends upon work as well as time. Now I will talk about the basic thing. Before explaining too much about the work done, I should go for scalar product or dot product. What is scalar or dot product? See, let A be the vector and B be the vector. Okay. So if I will draw like this, so it is your B and it is your A. Okay. And the angle between these two is theta. So how I will write dot product A dot B. So representation of this dot product is A vector B, and this is equal to magnitude of A magnitude of B into cos theta. Okay. So this is the dot product. It is scalar. Why it is scalar? Because it has no direction. Say product by itself, since A and B both are vector, but the dot product is scalar. It is scalar. Okay. It is scalar. Now I will talk about projection. If I want to tell you that find the projection of A vector on B. How you will find a projection of A vector on B? How you will find? See, projection means what? If there is if I will consider light is falling perpendicularly on the vector A, so its shadow will be formed. Where does this shadow will form? Does this shadow will form? See here, its shadow will be formed at this point. See, at the shadow of the vector A is this length. Okay, this length. So this is the shadow. So this length, suppose I am taking O, P and Q, then OQ is equal to projection of vector A on B. Understood? So you can easily find the projection of A. So if I want to find OQ, so OQ, how you will find OQ? So basically cos theta is equal to base by hypotenuse, that is equal to OQ divided by A vector. Okay, so OQ can be written as written as A cos theta. OQ is written as A cos theta. I hope you have understood. Okay. Now I will talk about properties of vector A and B. If I will talk about properties of vector A and B, so basically A dot B is equal to B dot A. It is your commutative property. Dot product is distributed. See, A dot B plus D can be written as A dot B plus A dot C. Dot product of a vector with itself gives a square of its magnitude. That is, your A dot A is equal to A dot A is equal to A cos theta. That is A dot A is your A dot A cos theta, that is, it will be A square. Why? Because the angle theta with the same vector. For example, this is your vector A and this is a vector A. So angle between vector A with itself is your 0 degree. So here you can put 0, cos 0 is 1. So cos 0 is 1, so you will get A square. Now A dot lambda B, where lambda is your any scalar, so it can be written like this: lambda into A dot B. For example, 4. If vector A is there, A into 4B. If there is a dot product, so we can write here 4 outside, and I can multiply it or do the vector A dot B. Okay, where lambda is any real number. I dot j is j dot k and k dot I is equal to 0. So what is I dot j? So suppose there are a three-dimensional figure. I am talking about three-dimensional figure. There is I cap, there is a j cap, there is a k cap. All are unit vector and showing a direction. So we know that all are perpendicular to each other. So if I will take I dot j. So it means that I j magnitude of j cos 90 degree, and if cos 90 degree, because there is a 90 degree between I and j, so it will be 0. If I am talking about j dot k, so it will be the magnitude of k into cos 90 degree. So this will be j. So similarly I dot k, this has also 90 degree. So I can write here I dot k is also I dot k or k dot I is 0 degree. And see here I dot I is equal to 1. Why it is 1? Because it's the magnitude of I into angle between them is 0, because it is the vector making an angle with itself is 0 degree. So this will be cos 0 is 1, magnitude of I and magnitude of I is 1 only, because it is a unit vector. So I dot I, j dot I, j. Similarly j dot j is equal to k dot k, you can write here 1. I hope you all have understood now. Now I will talk about work done by a force. Okay, how work is done by the force. So let us draw a diagram. If an object is placed on the surface like this, and a force is being applied at this direction. Okay, so if force is applied in this direction, which is making an angle theta, so what will happen? So this object will be displaced at a distance d. This object is displaced at a distance d. Okay, so if displacement is d, so what will happen? If displacement is d, then what will happen? Try to understand here. So by which force it is displaced? Definitely the component in a horizontal direction. Due to this only this displacement happens. Means to say, we have two component of the force. That is your F sin theta and it is your F cos theta. So who is responsible for the displacement? F cos theta. So work done is your force into displacement. Work done is equal to force into displacement. If I am taking work done as WD, so this will be force. But which force is responsible for displacement? So definitely it is your F cos theta. And into displacement is D. So we can write here D. So finally work done is equal to F D cos theta. So you know that F D cos theta means, can we write here F dot D? So vectorially if I will take work done, so what will be the result? It will be work done is equal to F dot D. Now I am talking about unit of work. So unit is your, since work is energy. Work is energy. So if work is energy, so energy has a unit joule, so work done has also energy as joule. Okay, I hope you all have understood work done. I will try to solve the some problem. It is saying that find the angle between force F. So force F, it's a force F, and the displacement D. Also find the projection of F on D. So angle between these two vectors. So we have how many vectors? Two vectors. So in this direction there is a displacement D, and suppose I have a force is in this direction, and the angle between these two is theta. So how to find angle between them? So if we will take F dot D, then we will get F magnitude of F into magnitude of D into cos theta. So we know that how to multiply F dot D. So by using this 3I plus 4J minus 5K dot 5I plus 4J plus 3K, and this is equal to magnitude of F. It means here magnitude of F. So as here it is your 3I, so root under 3 square plus 4 square plus 5 square into magnitude of D. So magnitude of D means what? This section we have to take. So 5 square plus 4 square plus 3 square and into cos theta. So it will be 5 3 is 15 plus 4 4 is 16 minus 5 3 is 15, and this is equal to root under 3 square means to say 9, 4 4 is 16 plus 5 is 25. So basically it is 50 into root 50 into cos theta. So if I will talk about cos theta, so this will be cos theta is equal to how much? This 15 got cancelled. So 50 into 50, it's root 50 into root 50, it will be 50. So basically cos theta is equal to 16 by 50. Okay, understood? So we have got angle theta. So theta will be equal to cos inverse 16 by 50. Okay, I hope you have understood. Now in second part in question they are asking about, the projection of F on D. So projection, basically when we talk about projection of F on D means what? We are talking about this length. So what will be this length? So projection of F on D. So how you will do this? So projection of F on D is equal to F cos theta. So force is how much? Root 50 into cos theta is how much? Cos theta is how much? Cos theta is your 16 by 50. So basically we will get 16 by root 50. So this is the projection length. So this length, I am talking about this length. So we have got this length. Now, notion of work, notions of a work and kinetic energy. The work energy theorem. So we need to derive work energy theorem with some notion. Okay. Now let us consider some of the object. Okay. Let us consider this is an object. It has having mass m and it has initial velocity u. After a certain distance traveled, this mass is same, but v is your final velocity. Okay, v is the final velocity. V is the final velocity. So let m be the mass of object. Mass of object. U is your initial velocity. V is your final velocity. Let us consider distance travel is your s. S is a distance travel. And t is the time taken while distance travel. T is time taken. Now we know that whenever any velocity changes, it means that force is being applied. So let us consider F is the force is being applied. F is the force being applied. Okay, applied for time t. So can I change S? Now, as we have understood that if force is being applied on a mass m, so its initial velocity changes from u to v, and distance covered on that time is d, and the time taken is t. Okay, and mass is m, and force applied for the on this object is f. Now, as per equation of motion, as per equation of motion, what we can write, can we write here v square minus u square is equal to 2 into acceleration into displacement. Now multiply all equation with 1 by 2 m. So what will be the result? So definitely result will be half mv square minus 1 by 2 m u square is equal to m a into d. Now if I will talk about initial kinetic energy, so ki, can I write here 1 by 2 m u square? And if I will talk about final kinetic energy, that can I write here half mv square? So ki is initial kinetic energy, and kf is the final kinetic energy. Oh. Now let's give us some space so that I can complete this. Okay. Now half mv square minus half mu square is equal to mad. Okay. Now if I will talk about ma is what? Force applied. So F into d, and this is equal to kinetic final kinetic energy minus initial kinetic energy. And if you talk about the vector, since force is also vector, d is also vector, so can we write here F dot d, and F dot is d is your what? Work done, and this is equal to final kinetic energy minus initial kinetic energy. Okay, or we can say that work done is equal to change in kinetic energy. So what does work energy theorem states? So from here we can say that as per work energy theorem, work energy theorem, work done by a force, work done by the force is equal to change in kinetic energy. Change in kinetic energy. I hope you all have understood this. So this is the basically notion. So this is very important theorem, and so many places we can apply this work energy theorem, right? Now I will do some numerical. It is well known that, see, I will do some numerical, but for the next part, I hope you have understood. Thank you, everyone.